Pascal's triangle. In this problem, we're given an integer num rows and we need to return the first num rows of Pascal's triangle. If you don't know what Pascal's triangle is, it's basically a triangular array of numbers where the first row is or has a value of 1, just a single 1. And for the subsequent rows, the first element is always 1 and the last element is always 1. So as you can see in the third row, it starts with a 1, it ends with a 1. In the fourth row, it starts with a 1 and it ends with a 1, so on and so forth. And every other number in a row is actually the sum of the two numbers directly above it. So this visual representation actually gives us a good idea about what's going on. As you can see, the first value of every row is a 1 and the last value of every row is a 1. And for every other number, like the 2 here, it's actually made up of the two numbers added above it. So the 1 plus the 1. For example, the 3 here is made of the 1 plus 2. 3 here is made out of the 2 plus 1. And concisely, in Pascal's triangle, each number is the sum of two numbers directly above it. So what we need to do is we need to return a list of list integers. Now, what's going to be in that list of list integers? Well, they're going to give us an int num rows. So let's say they gave us 3. What we need to do is in our list of list integers, we need to place the values of each row in a list and add them to a bigger list. So for int num rows of 3, inside a huge list, we need a list containing the single 1. We need another list containing 1, 1, and we need a third list containing 1, 2, and 1. If we had 5, we'd return the first 5 rows. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So it goes without being said. The first thing we need to do is we need to create that huge list. So let's go ahead and do that now. So list of list integer, and we're going to call this list is equal to new linked list. Now there are some minor cases we need to consider. For example, what if int num rows is equal to 0? Then we need to return an empty list. So if num rows is equal to 0, return list. Well, what about if num rows is equal to 1? Then all we need to do is we need to return this 1. But first we need to put it in a list of its own. So first we create a new list, a list of integer. We can call this list 1, which is equal to new linked list. And within this list 1, we're actually going to add just a 1, and then we need to add to our big list list.add list 1. And then finally what we need to do is we need to return the list itself. Now if num rows is equal to 2 and we need to return the first 2 rows, then we're going to just copy this, add it here, and we're also going to create another list of integer. We'll call this list 2, which is equal to new linked list, and we're going to add to list 2 1, and then we're going to add another 1, and then we need to add to our big list 2, and then we need to return list. So now if num rows is 3 or greater, this is where we automate the process. So the first thing we're going to do is, given the first 2 rows is just a bunch of 1s, we're actually going to copy the blocks of code in num rows equal to 1 and num rows equal to 2 without returning list. So in other words, we're going to create a list for the first row and we're going to create a list for the second row. So list 1 now contains 1 and list 2 contains 1, 1, similar to the if statements before. And now our big list contains 1 and it contains 1 and 1 as well in another list. So our big list contains these 2 lists. Okay, so now we need to tackle any other case. And by any other case, I mean anytime num rows is greater than or equal to 3. And to quickly mention something, in our big list, currently with these 2 values, this list is at an index of 0 and this list is at an index of 1 in our big list. So if I wanted to retrieve the first list in our output, then I would just do list.get0 and I'd get this list. If I did list.get1, then I'd get this list. And this is important for the next step in our solution, because what I'm going to do now is in a for loop starting at I equals to 2, which means the list that needs to come after this one. In this case, it's 1, 2, 1, but our big list is actually empty right now. But our big list just contains these 2 lists right now. As long as I is less than num rows I++. What we're going to do is we're going to create a list of integers similar to our if statements. I'm going to call this list list_x, and it's going to be equal to new linked list. The reason I'm not naming it more specifically is because first, I don't know how many num rows they want us to return, and second, because every time we loop back to this for loop, we're going to create a new list. Now, the idea in these two lines of code is, like I said, we're starting at index value 2, so the list that's supposed to come after this one. And we're going to keep looping while I is less than num rows. And so basically this statement tells us how many rows we need to add to our big list, or how many lists we need to add to our big list. And this list of integer is the list for each row of values we want to add. Now remember, always in Pascal's triangle, the first value of each row is always 1. And so that's exactly what we're going to add to our list x. So list x dot add a single 1. So now I'm going to create a nested for loop, and I'm going to write it out and then I'll explain what it does. Okay, so the idea with this for statement is we're going to access the list right before the current list that we're creating. So for int I equals to 2, in this for loop we're going to access the list before I equals to 2, which is I equal to 1, which is this list right here. And we're going to create a pointer y, which is equal to 0, which is going to look at the very first element in that list. In this case, it's 1. And we're going to keep looping while y plus 1 is less than list.get I minus 1 dot size. So first of all, list.get I minus 1 is referring to the list right before the one we're creating. Dot size means the number of elements in that list, in that sublist. And why are we looping while y plus 1 is less than not just y? That's because the idea is I'm going to add y to y plus 1. Y, which is 0, which is pointing at 1, we're going to add to it the value that y plus 1 is looking at. Y plus 1 is 1 in this example, which is also looking at 1. So we're going to add 1 plus 1. And so we want to make sure that the y plus 1 does not go out of bounds. Let's say we want to create row number 4 of Pascal's triangle. We're going to access the list right before it, which is 1, 2, and 1. We're going to have a pointer y, which looks at 0, which looks at the value of 1. We're going to add to this value of 1 whatever y plus 1 is pointing at. Y plus 1 is 1. The value at 1 is 2, so we're going to add 1 to 2, and that's 3. And then obviously we're going to add that to the list that we're creating the row for. After that, we're going to increment y, so y is now 1, and y plus 1 is 2. So we're going to add these two values together. And once we increment y one more time, y is going to be looking at this value, but y plus 1 is now out of bounds, and we exit this for loop. We created a list x for each row, for the current row that we're on. The very first value we're going to add is a 1. Now in this for loop, we need to add the other values, which are the sum of the two numbers directly above it, which in other words are the values that y and y plus 1 point to in the list before the current list that we're creating. And so after we add 1 to our list x, we're going to add to our list x again the value of, first we need to retrieve the list before the current list that we're working on, and so that would be list.get I minus 1. Now that we're referring to the sublist before the current one that we're creating, we can now access the elements within it. So what we need to do, since we're looking at a list of integers, we need to get within that list of integers the value that y is pointing at, and we're going to add to it. Once again, we need to retrieve the list before the one that we're currently working on, so I minus 1, and we want to get from that list what y plus 1 is pointing at, and that's it basically. Now what we need to do is, once we finish this for loop, like I said, in Pascal's triangle, the last value of every row ends with a 1. And so what we need to add to our list x finally is another single 1. And then all we need to do is add to our big list, list underscore x. Finally, all we need to do is return list. Let's submit this code and see if we have any errors. Okay, so I have a typo here. This is num rows, not nums row. Okay, accepted. So that was Pascal's triangle. I hope you found that video helpful, and thanks for watching.